Okay, students, so next topic is differentiability. Okay, now in class 11 we have discussed derivative in detail, right? Now what was derivative you need to know again. Well, then only we can understand differentiability here in class 12, and in class 11 only I told you that your base of calculus is your limits and derivative. Okay, so to understand derivative again, see here what we have discussed was, with the help of derivative, in a curve, if it is a secant, suppose this line joining 2 points here, this was the derivation we have done in class 11, right? Secant. Now if I want to write slope of this one, what was the value of this one? We have taken there x1 y1 like this, right? If y1 means I can write f of x1, right? And this one will be x2 f of x2. Remember, I hope, little bit. So just to recall back all this, I'm discussing this one a little bit, okay? Because this is again your base. There will be a theorem called for continuity. If you want to check without solving that problem the way we have done in previous exercise, you can check for differentiability. Whenever a function is differentiable, it is also continuous. We will have the theorem. To understand the theorem, you need to understand derivative very well, okay? So this 2 point, right, we have taken, suppose from here to here it is x1 distance and this one y1. So we take the coordinate of this point will be x1 y1. Now y1 I can take f of x1 also, right? This is what your y1. Now this is from here to here, it is suppose x2, and this is f2, suppose fx2. Okay, y2 means fx2 I can take, right? Now we have taken last time, remember, this distance, suppose delta x we take, very small distance. Okay, now the slope of this line we can easily find out. What about slope of tangent? If you want to find out slope of tangent, now how we will find out? This secant, what you can do is, you can hold this one and can bring like this. If you bring like this, what will happen? This line will move like this, and a time will come that it will touch only one point, this line, right? So it will become tangent. This secant will become tangent if you keep on moving the line. Let me draw a little bigger, like this. If you keep moving this line, fix this point and move this line like this, then what will happen? It will move like this, right? Like this it will move. So a time will come when it will pass something like this, so it will become what? Tangent or not? Yes. Now same concept here. See here, from this secant, if you want to make it tangent, what you have to do is you have to move this. Now whenever you will move this one, what will happen? This distance delta x, this is your x1. Let me make a little clear here. This is your x2 from here to here. Okay, now this distance from this to this, the difference between x2 minus x1, you can say x2 minus x1 is nothing but, I will take delta x. Okay, we have taken like that, right? In class 11 we have discussed. So if I hold this one and move like this, what will happen? It will become a tangent. So remember slope, how we used to find out? y2 minus, when we know 2 points, what will be the slope? y2 minus y1 by x2 minus x1, right? Now if I want to find the slope of tangent, you have to move this line like this. Now when you move this one like this, what will happen? This x2 minus x1, let me write down here y2, let me write down fx2, or let me write in this page, this y2, this is your y2, right? y2, what I can write in terms of y1? Can I write y1 plus this portion, right? Okay, let me write down here itself f, this y2, what I can write? F of x2, right? Minus f of x1. Now this x2, can I write in terms of x1 only? x2 means what? This is your x2, right? x2 means x1 plus delta x, x1 plus delta x minus fx1 means I am introducing only one variable, that's it. Now see, this one I got it, right? Now see here, slope will be what? y2 minus y1, that is this minus this, plus delta x minus fx1, y2 minus y1 by x2 minus x1 is what? Delta x we have taken, right? Now see, if you want to make this one tangent, what you have to do, you have to move this one like this, right? When you move this one like this, what will happen to this distance? It will become smaller. When you move this one, it will be here, this point. Then what will happen? This delta x will become smaller and smaller, smaller and smaller. You keep on moving, smaller and smaller. And a time will come when this will become tangent. The moment this will become tangent, this delta x will become 0. Right? Now, what we have understood is, if I can make delta x 0, I can make this line tangent. Means slope of tangent also I can find. But the problem here is, if I take, this is your slope, right? Slope of secant. Now if I want to make this one itself slope of tangent, I can make, right, by making delta x 0. Now if I take delta x 0, what you will get? 0 here in the denominator. Numerator, what you will get? fx1. This will become 0, right? fx1 minus again fx1. Now if you subtract this one, you will get 0 by 0, which is indeterminate form. Now indeterminate form you cannot work with, right? So for solving this kind of problem, what concept we have again? Limit. So instead of taking 0, this delta x 0, what I will do is, I will not take directly 0, I will take limit. Means I will take tends to 0. Delta x tends to 0. This is what the concept of limit is, right? It helps you finding the value of indeterminate form. So fx1 plus delta x you can take h also, small h, delta x1 minus x1 by delta x. So as your delta x tends to 0, this whole thing will become slope of tangent. So this is denoted by tan of x also and dy by dx also. This is nothing but your derivative. Okay, now same concept, it is used in finding rate of change of velocity also, right? Rate of change of velocity, how you used to draw graph, same thing. If you want to find out at a particular point the rate of change of velocity, like for example I said, right, last time, if a vehicle is moving, okay, suppose with a speed 20 km per hour. Now when this is given, it is given in terms of average value. Now if I ask you, after half an hour, what was the exact speed? At that point you cannot say. If I say 20 km per hour, this is the average speed. Okay, from initial to end they used to find out the speed and find out the average of that one. That is your speed, 20 km per hour. But if I want to find out at instant point, at this point, exact point, what will be the speed? Then you cannot use this average concept. In that case, you have to use this rate of change of velocity, that is derivative you have to use. Okay, at a derivative give you at a particular point what will be the speed. Okay, at this point what will be the speed, at this point what will be the speed, at this point what will be the speed. This will give you by derivative. At instant point it will give you the speed. Okay, so that is how derivative you can say it is precise to find out the speed of particular object, you can say. Okay, so in case of launching rockets and all also, they used to do calculation with the help of derivative only. Okay, so you will understand that one later. First we will try to understand the meaning of this one. Okay, so this was the derivation. This is also called principle of derivative, right? Remember, so using this only we have find out many formulas. Dy by dx, suppose y is cos x, then what will be the derivative of this one? So derivative of this one we have already discussed in class 11. By using this principle of derivative only we have proved this one, right? And it used to come out to be sine of x. Now this one we use as a formula. In this way many formula we have derived, right? So those formula we will use. You can say this one is a shortcut only. We cannot always try to find out this one, solve it like this using principle, because it will consume time. So what we have done is, using this formula only we have derived for some particular trigonometry function and some polynomials also. We have derived formula. Those formula we use in other kind of problems to solve it. Okay, so that it won't consume much time. So y equal to x, when your function is cos x, its derivative is minus sin x. In this way, for sin x it is cos x, like the many are there, right? So those identity we have already done in class 11. Okay, so I hope you remember those identity also, even though I will send you the image of those identities again. I will note it down and will give it to you. Okay, you just try to recall back all those things. And based on this derivative, we have also studied how to add, how to subtract,